Hi, everyone. We're going to take a look now at the questions on 267. Now, to be able to do these questions really good, I would like you to go back and do the work on it if you haven't already done that. Now, on the work on it, on the procedures, I would really like you to do procedure one, two, three, four. I'm going to leave five as optional. That's design a poster, a model, or brochure. I'll leave that optional. But the other four parts in the procedure are really going to help you gain knowledge on that. So before we do the communicate, we'll actually take a look at the think again, ask, discuss, and review on page 267. Okay, question number one was what makes the bands of color found on Jupiter? Okay, so, and what is the giant red spot? Now, there are massive winds on the planet, so the atmosphere of Jupiter is spinning rapidly, and it creates all these different bands of color from the wind moving the atmosphere so quickly. Now, the big giant red spot on Jupiter is not actually a spot, but it is a massive storm that has been going on for centuries. Question number two, is Saturn a heavy, dense planet? Explain your answer. Well, actually, Saturn isn't that heavy. It's actually not a very dense planet, and it rotates extremely fast. If you took a really good observation of Saturn, you would actually notice it's more balloon shaped than actually ball shaped. What is what is different about how the planet Uranus spins? Now, it is kind of an anomaly in the solar system. It essentially rotates on its side. So instead of spinning around this way, like pretty well all the other planets, it actually spins on its side instead. Four, why is Neptune sometimes called a big blue popsicle? Now, you have to remember that planets like Neptune are so far away from the sun that a planet like that actually releases more energy than it is gaining from the sun. So it is essentially a giant gas frozen popsicle. The communicate questions. Prepare a report about how one of the about one of the planets of the solar system used descriptions, pictures, and drawings. Okay, I hope you guys did do one on one of the planets. Two, well, that can be optional. If you created a game, could you please play that game to one of your younger siblings or another classmate to help them learn about the planets? And number three, I kind of find to be a little bit of a trick question. Create a scale distance and or a scale size model of the major components of the solar system. Okay, so if we're building a scale model, we could possibly do that if we had an 8-foot ball to represent the sun and maybe a little marble to represent the earth. That's kind of possible, I guess we could say, but to do a scale distance, I wonder if you guys remember that video I showed you earlier on in the year where the guys built an actual scale model of the solar system. So let's say we set up the sun on the uh, right on top of the school. Well, if we were to go out to Neptune, Uranus, Pluto, well, to make that model accurate, we'd probably have to drive all the way to Belle Plaine to set up our little marble. Hi, guys. Since I do not have a copy of the textbook, what I want to do is to share a little more information on the gas giants that I actually have from the teacher's guide. I'm not sure if all the information is in your textbook, so I thought it'd be probably a good idea to just read the background information that I have for you. Okay, so Jupiter was the planet that Galileo Galilei turned his newly developed telescope to in 1610. He discovered four of Jupiter's moons. What Galileo could not see is that Jupiter was a very small, or pardon me, Jupiter has a very small rocky core that is surrounded by a liquid metallic hydrogen. Because Jupiter is so large, the pressure from the planet itself has compressed the liquid hydrogen into a more metallic form. This metal layer is surrounded by another layer of liquid hydrogen and helium. Because of its large size, some astronomers believe that Jupiter could have become a star. And actually, a lot of sci-fi movies have done that. They estimate that if it were just 50 times larger than its present size, its core would have collapsed upon itself, generating nuclear fusion. The process of nuclear fusion gives stars their energy. The bands of color we see on Jupiter are caused by the gases that make up its atmosphere. These gases spread out because of the speed at which Jupiter rotates on its axis. Jupiter has the fastest rotation of any planet in our solar system. Around Jupiter, there are 63 moons and 3 sets of rings. The rings are 5,920 kilometers in width and only 1 kilometer thick. They weren't discovered until Voyager 1 probe beamed back images in the 1970s. Saturn spins so quickly that it bulges at the equator, giving it a sort of squash football shape. Saturn is similar to Jupiter in many ways. It is believed that it has the same type of core and layers, and even their atmospheres are similar. Saturn's cloud layer is thicker, and its atmosphere tends to be cooler than Jupiter's. Saturn's most famous feature is its rings, which were discovered by Galileo in 1610. He thought they were attached to the planet, but in 1659, astronomer Christian Huygens showed that they are not. Saturn also has numerous moons. The one that scientists are most interested in is the moon Titan. It is larger than the planet Mercury, and it may be the only moon in our solar system to have an atmosphere. Scientists want to study this moon because it may be similar to what Earth may have been like a long time ago. Uranus is named after the Greek god of the sky. This planet was first discovered by William Herschel in 1781. It was the first planet to be discovered using a telescope. Herschel had seen this planet many times but had originally dismissed it as a star. Made of rock and ice, this planet's axis of rotation is on its side. It is believed that this drastic tilt was caused by a large object colliding with this planet early in its formation. Like other gas giants, Uranus has many moons and a thin set of rings surrounding it. Neptune is now the farthest planet from the Sun. Neptune was discovered on the basis of mathematical calculations. It has been difficult to observe in the past because of the interference of Earth's atmosphere. But with advancing technology of Earth-based telescopes and the Hubble Space Telescope, much more has been and will continue to be learned about this planet. Neptune has rings, multiple moons, and 2 spots similar to Jupiter's Great Red Spot. In 2006, the International Astronomical Union, the IAU, adopted an official definition of a planet. According to this definition, to be considered a planet, an object must orbit the Sun. Be massive enough so that its own gravitational forces shape into a sphere, so a hydrostatic equilibrium. There's a $5 word, eh, Megan? Have cleared the neighborhood around its orbit. So when it clears the neighborhood around its orbit, it's going to pull like meteorites or asteroids that might be in its orbit into it. According to this new definition, Pluto is no longer considered a planet because it does not meet the third criterion. It is part of a sea of other celestial objects that occupy the same region of space. This definition has not been accepted by all astronomers. Some still think that Pluto could be considered a planet. This example can be used to illustrate the science that science evolves and theories change based on new information. So I guess the astronomy world, the Pluto, the anti-Pluto and the Pluto supporters are kind of like the Bloods and the Crips or Montagues and the Capulets. Um, just a little bit more on this discovery of Neptune. Neptune was discovered because the orbit of Uranus was slightly different from the way it should be. Astronomers hypothesized that there must be another planet nearby that affects the orbit of Uranus by its gravitational pull. Based on the location of Uranus, astronomers calculated the location of Neptune. Neptune was finally observed through a telescope by Johann Galle in 1846. The discovery of Neptune is a good opportunity to discuss the nature and progress of science. If a hypothesis is unable to adequately explain observations, a new hypothesis may be suggested, and experiments, observations, and calculations are made to verify the new hypotheses. In this way, scientists continually add to what was done in the past, and we gain more and more detailed knowledge about the universe we live in. Now, there's some interesting studies that are going on right now. There's some astronomers out there that actually believe, based on some of the mathematical observations they've seen, that there's another planet out there that we haven't been able to find right now. They call this possible planet Planet X. So scientists are observing I believe, the orbits of Uranus and Neptune, and they're seeing a little glitch with those orbits they have that just isn't quite explained, and they think there might be another planet out there that is affecting their orbits. Maybe in our lifetimes, we'll have another planet for our list.